Our next speaker is Dr. Kent Anderson from Zoetis. He is the Zoetis Genetics Assistant Director of Technical Services. Kent was raised on a diversified livestock farming operation in Nebraska. He has a PhD from Colorado State. He spent many years as the Vice President of North American Limousin Association before joining Zoetis. That is not, the picture's not Kent, but we wanted a picture with some of a hat on. He usually wears a big hat. That's Donald Brown, if you have been to R.A. Brown Ranch in Texas. So without further ado, Charles Liebergreen's going to hopefully bring Kent on in.
Rightio, and Kent, we're ready to go. Thank you very much for joining us this morning. I think Luke's going to wind up the audio from your end, and you're away.
Great, thank you, Graham, and thank you, Charles, and thank you, Beef and Lamb New Zealand, for this opportunity to participate in your Breeders' Forum. Two objectives for this morning would be to first acquaint you with some of the things we're doing here in the U.S. to integrate genetic selection and breeding tools for both feedstock and commercial producers. And the other objective is to try out some around-the-world technology and some audience interaction in the process. Before I begin, I'm going to stop there just to make sure our sound and video are all working appropriately.
It's good, Kent. We'll just have to tone back your excitement and get you to talk a little bit more softly. There's a little bit of crackle, but it looks great.
Very well. To help set the stage for the visit we're having this morning, there are 2 points that I'd like to make on this slide. We now have our HD50K high-density marker information feeding into genetic evaluations to inform genomic-enhanced DPDs for a variety of breeds. Those currently include Angus, Red Angus, Hereford, Simmental and Sim Angus, Limousin, Gelbvieh, and by the year end, probably a variety of our Bos Indicus breeds. So while I'm going to speak about Angus examples today, please be aware that for the most part, this technology has been now integrated into most all of our different breeds at the seed stock level and into their genetic evaluation. The second thing I was going to point out to folks today is that I'm going to talk about the additive, inherited genetic merit of animals and evaluating that. By all means, all the non-genetic elements sure need to be synergized and matched with genetic potentials in order to really see the expressed productivity gains that we all want to derive from Angus. I'm going to speak with you about what we term our Angus genetic game plan, and advanced apologies for not using a rugby example. But as in rugby, so is the case in U.S. football, whereby we really have to have a good offensive game plan as well as a good defensive game plan. And as we visit with our producers here, we like to characterize the analogy of using genomic-enhanced EPDs, or in your case, genomic-enhanced breeding values, to make the best bull selections possible. Have those decisions made on the most accurate genetic predictions, as well as the most comprehensive set of predictions for the hard and difficult to measure traits. On the defensive side of the rugby or football game plan, we've now developed 2 downstream tools under the GENEMAX category to aid in replacement heifer selection and feeder cattle evaluation. And so I have just a few slides to talk about relative to the overall breeder perspective, and then the remainder of the visit will be about the GENEMAX advantage for commercial users of Angus genetics. I wanted to share with you an overview of the genetic strategy here in the U.S. relative to our Angus application, but this is envisioned to be integrated into other breed and breed cross offerings as well. As many of you are aware, we do have the fortunate reality in the Angus business of having certified Angus beef as our end product target goal at the end of the supply chain. Similar to you, we are a pretty segmented business where we have very definite seed stock producers that provide bulls for commercial cow-calf producers. Generally speaking, those calves are marketed at weaning time, fed in feed yards, and then they go through a packer and retail distribution network. As we've built these DNA tools here in the U.S., we've done so from the foundation of an Angus breeder-led approach at the high-density seed stock level, the genomic enhanced EPD or breeding value level. And then we've taken what we've learned from this breeder's edge approach, breeders-led approach, to build downstream tools in the form of GENEMAX Advantage and GENEMAX Focus for commercial users of Angus genetics. And so I want you to think about these tools as being connected, as being synergized, and as being complementary to one another, whereby the more we learn about the seed stock, the more we can then predict at the commercial level differences in genetic merit, and we can then deliver a complete game plan to producers. I have two slides where I'd like to just detail what is going on at the Angus breeder seed stock level. So many of you are probably aware that in genetic evaluation, we have multiple sources of information feeding into EPDs. The foundation, of course, is good, authenticated, verified pedigree information combined with the animal's own birth, weaning, yearling, scan, and other performance data. And really what we're trying to do with our high-density genotyping is jumpstart the accuracy associated with EPDs and indexes, and do so in a timely and costly way whereby we don't have to necessarily wait so long for progeny performance information to accumulate and contribute to the accuracy of the EPDs. So the short story is we're trying to use the markers to gauge sampling, whether animals got a good, average, or bad sample of genes for different traits. And we're trying to use that then to jumpstart accuracy and provide the equivalent of an initial progeny proof to the accuracy of the breeding values on animals. The best way we've found to communicate that to commercial producers as well as breeders is by using the terminology progeny equivalence. Progeny equivalents answer the question, how many records on offspring, daughters, and carcasses would it traditionally take in order to achieve the same level of accuracy that our high-density genotypes provide immediately? So across the maternal traits, buying bulls here in the U.S. that are tested and have GEPDs is the equivalent of buying a bull that already has 14 daughters worth of information contributing to their proofs. On the growth and efficiency front, buying tested bulls with GEPDs is like buying bulls that already have 17 offspring with all those performance measures contributing to their predictions. And on the carcass front, it's the equivalent of buying bulls with 10 progeny that already have carcass data available. Just a couple of traits to pull out of the list on the left of this slide. There's several traits that are very difficult, time-consuming, and expensive to measure, namely dry matter intake. And so we're using the technology to be able to deliver predictions for those traits in a timely fashion so that those can impact those yearling bull and female selection decisions. Also, before I leave this slide, I just want to mention that we now have over 40% of the U.S. Angus animals being tested that are females. And so what breeders are doing is they're testing females, getting EPDs that are more accurate than almost 2 lifetimes of natural calves whose data contribute to the predictions. And what that's doing is it's empowering smarter mating decisions throughout the lifetime of the female so that she can then maximize the value she creates for the breeder and for the breeder's customers. So as we discussed at the beginning, we've taken what we've learned now through really widespread adoption of 50K on the Angus seed stock front, and we've begun to create tools for commercial users of Angus genetics. And these are very new tools. They were just introduced to the market in the latter half of 2014. And so what I'm going to talk to you about next is really oriented towards commercial producers. So these would be non-registered cattle that are out of cow-calf producers that buy bulls from Angus breeders. And specifically, the tool I'd like to talk to you about is called GENEMAX Advantage. Currently, this tool is only available in the U.S., but our vision is that as we work with breeders in other populations of cattle, as well as in the Angus population the world over, we can take what we learn from the seed stock animals and then apply those to tools that can be used at the commercial sector. And the tools are integrated so that the bull selection synergizes and enhances then the replacement female selection. And this tool that we're going to talk about now is GENEMAX Advantage for replacement heifer selection. Now, I've not traveled to New Zealand, but in my experiences in North and South America and other parts of the world, for hundreds of years, the main way in which we've selected our replacement heifers is through visual appraisal. And, you know, we can do many, many things that are very critical and important visually. We have to make sure the replacements are structurally sound and of good feet and legs. Here in the U.S., we like moderate mature size and width and depth of body, animals that look to be adaptable to forage and grass resources. You know, visually, we can study these heifers and we can pick out those that may have disposition, temperament problems. And in no way, shape, or form do we want to diminish what we would term the good cowboy common sense of visual evaluation of structure and type and fleshing ability and all those things. But this tool is meant to go a little bit beyond that and look at things under the hide or those things that we cannot see visually. We know we also can do a better job of selecting replacement heifers by doing things like keeping the earliest born. They're likely to be cycling more times prior to the start of the breeding season and then get pregnant early in the breeding season. Many customers here would work with their veterinarians to evaluate reproductive tracts, in other words, cyclic activity at a year of age in advance of the breeding season to sort off those that may be late puberty or free martins, or in some cases we even find heifers that are already pregnant and got bred on the cow. Some of our most advanced producers would have production records on the dams of animals and use that as well. But I would say that here in North America, for the most part, 95% of our selection decisions are really driven visually. And I would humbly submit to the group that sometimes when we do that, we're not necessarily selecting on traits that yield the most long-lived and profitable cows. To say that a different way, I can't look at these three heifers in front of you and necessarily tell you the one on the left has the highest genetic merit for inherent fertility. Nor can I look at them and say, hey, the one on the right has genetic merit for feed conversion and CAB carcass merit that's going to be profitable post-weaning. So for all the things in the unseen world that commercial producers can't necessarily evaluate visually, this tool is meant to augment and to provide additional information on two fronts, both for the selection or the keep cold decision, as well as to the decision as to what these females are bred to, either AI or natural, throughout the lifetime of their productive service. So we'd like to set up a little example and around the world audience interaction. And I'd like you to put yourself in the shoes of cattle producers, which you are, and study these four heifers that we've got pictures of. And I'd like you to think about which one of these four on your operation has the look of making the best and most profitable cow. And advance apologies for the livestock photography. I don't have a future in that field, obviously, but these were the best pictures we could get at the time. And I'd like to have you study these and find one heifer that you like relative to femininity, depth of body, structural correctness. And we want to stop here now, and I believe, Cheryl, you're going to use the audience response system. We're going to take a little poll visually of the collective selection of this group, and then we'll detail this product and share with you the results. So, Cheryl, I'm going to stop there.
Thanks, Kent. That's great. We have, this technology is working great. We did have one failure, and it's with these devices on your table, so don't worry about those. I'm going to ask you all to be very brave, and I know that we're going to show Kent a thing or two here about our visual selection practices in New Zealand, and I'm going to ask you to select one and put up your hand, all right? So who would choose heifer number 1? Okay, so quite a few. Who would choose heifer number 2? Not as many. Who would choose heifer number 3? Ooh, I'd say that's about halfway, perhaps. And who would choose heifer number 4? And not many at all. So I would say it's pretty close between 1 and 3, Kent.
Excellent. Cheryl, do you want to have anyone comment on why they may have chose 1 or 3, or shall we proceed?
Right, who's closest? I was fortunate enough to stay at the Stake of Origin quite late last night, and same person was with me very late last night. So, Charlie, would you like to?
Well, I actually I chose number 3. I like to have some depth of water on that animal.
Okay, there's the microphone there. If you're talking to that, I think Kent will be able to hear you as well.
Yeah, I'm just saying I actually chose number 3. I like the depth of hind quarter on the animal, and I like the femininity. I thought she had a good head. So that was my picture.
Great, thanks very much, Charlie. And Kent, did you hear that?
I did. Thanks, Charlie. We appreciate your bravery. Cheryl, I'm going to proceed and detail this product, and then when we wrap up here in 5 minutes or so, we'll show the results, and we'll see how our eye evaluated these may be either the same or different than what our DNA assessment yields.
That's great, Kent. Carry on.
So, as mentioned, we've attempted to create this GENEMAX Advantage product so that it's really simple and easy to use for commercial producers. You know, we here acknowledged early on that to provide a commercial producer with genetic information for 18 or 20 different traits would just be overwhelming. So we've tried to really simplify and make this easy to use. As mentioned, we built this from what we've learned in testing now over 130,000 animals using HD50K. And the simplicity really comes from our attempt at marrying the DNA genomic-based predictions with both the dollars of cost associated with production as well as the dollars of revenue generated from production. So it's built from the foundation of 50K and designed to be simple and easy to use. As mentioned, GENEMAX Advantage is interconnected and related to HD50K for Angus. Namely, if the heifers that are being tested or older females that are being tested are out of a multi-sire bull battery that have been tested on HD50K, we can assign specifically which sire produced which heifer. And the test is relatively breed specific in that animals need to be 75% or greater Black Angus breed composition. So ideally, again, that would be sired by a registered, transferred, breeder-led Angus sire, and then out of a black cow that's thought to be at least half Angus. I like showing this advertisement that's currently running here in the U.S. from the American Angus Association mainly to communicate the awesome challenge we have as seed stock and commercial breeders. We are asked to balance all these traits oriented towards maternal production, where females have to thrive and produce regularly on grass and forage resources. And we have to balance all these maternal traits that are of critical importance with then all the carcass things. And in the lower left of this slide are the premiums that have been paid out for certified Angus beef. And so breeders, be it at the seed stock or commercial level, have this very challenging task of trying to balance not only the visual and the important structure and function things, but also the predictions for maternal traits as well as the prediction for growth, efficiency, and carcass traits. So we've attempted to build these indexes to really give producers the tools to manage across those cow and feeder and carcass traits. This slide coming up is meant to give you a little more insight as to what is in the 3 different indexes that we call GENEMAX Advantage scores. The first GENEMAX Advantage score we call Cow Advantage, and the maternal traits that are included in Cow Advantage are DNA genomic-based predictions for probability of heifer pregnancy, for calving total maternal, which includes birth weight, direct and maternal factors, as well as it includes genomic predictions for genetic merit the cow passes on to her offspring for weaning weight growth. And then it also attempts to optimize the costs associated with varying levels of mature cow size as well as milk production. So those things are all included in the Cow Advantage Index. The Feeder Advantage Index picks up where the Cow Advantage Index leaves off and includes the following traits: gain in the feedlot, dry matter intake as a cost of production in the feedlot, and then also carcass weight, yield grade, and marbling or quality grade as evaluated on a certified Angus beef grid. And then the total advantage score is all-inclusive of all the above. So it ranks Angus-based replacement heifers for combined genetic merit for all the traits and weighted according to the cost and value of production. I also want to point out that underneath these scores are actual dollar difference values, but to make it simpler and easier for commercial cow-calf producers, we've scaled them on a scoring system from 1 to 100, with higher scores being more profitable, and they are normally distributed, and the score of 50 is average for a reference population that currently comprises about 15,000 animals. So think of it as a 1 to 100 score, 50 average. The higher the score, the better. Again, to foreshadow using a sports analogy, and be it rugby or American football, sometimes just staying in bounds or being able to put the ball down is really the game changer. And being able, as a breeder or a commercial user of Angus genetics, to determine where the boundaries are for certain traits, the threshold levels, if you will, and then being able to flag animals who are out of bounds, who may represent a problem or a difficulty, that can be quite valuable in our selection and our breeding decisions. So the second big category of features of the GENEMAX Advantage product is what we call smart outlier reporting. So as a default, we flag animals that have been tested for being in the 5% least desirable for high cow cost, out of bounds docility, and out of bounds tenderness. The product is delivered by Angus Genetics Inc. on their secured member website, and the customer can vary the proportion of animals that they flag for these reasons. So if in your case your feed resources are more limited and or expensive, you as the breeder could choose to represent and flag the 10 or 20% highest cost cows and have that augment your breeding decisions. One last note is our partners at Certified Angus Beef asked us to also identify the low and the high outlier animals for marbling. On the low front, that's meant to be able to inform our mating decisions to breed those females to higher marbling bulls. And on the high marbling front, by virtue of knowing the high marbling animals, it gives us more flexibility as to the bulls we might breed them to and still have a chance to make a Certified Angus Beef carcass. With that, I'm going to return to our four friends here. And Charlie, I believe you liked number 3 quite a bit for a variety of reasons. And if those of you in the crowd are gambling people, you can place your bets now as to which ones we predict using the genomic technology are the most profitable. And I'm going to flash up on the screen then the cow advantage, the feeder advantage, and the total advantage scores as freeze-branded on the sides of each of these heifers. We've also freeze-branded them if they were identified as having any outlier concerns that might augment a decision. I assume you can see the scores now that are up and freeze-branded on the sides of these heifers. Charlie, to your credit, you picked one that was right down the middle of the road for cow advantage. That'd be the first score, 54 on the left. A little better than average for the feeder advantage traits and just a tick better than average across the board. I would submit to you that using the DNA technology, the heifer number 1 would be the best for combined genetic merit for heifer pregnancy, Cavities maternal, optimum mature cow size and milk, and then still passing on growth genes to offspring for heavy weaning weight. She also does the feeder things quite well and is probably, at least by our estimation, visually, were you able to see her in person, the one choice if we were only keeping one. I think it's interesting to note that female 2 has the same total advantage score, but arrives there through different genetic merit. She's quite good and growthy, and if you could see her, notably bigger in terms of frame size. And sure enough, she's predicted to pass on tremendous growth and carcass merit to her offspring, as evidenced by her 74 feeder advantage score. But because she's rather large and presumably also of higher milk, she gets discounted some on the cow advantage score. So if we were to breed her and set her up so that we could be more confident in her female offspring making good cows, we'd want to breed her to a bull that would downsize her size and milk and probably accentuate heifer pregnancy and Cavities genetics. The last and perhaps most important point I'd like to make on this slide is female number 4 is pretty sorry and unfavorable across all of the traits. She scores low in the maternal traits on the cow advantage score, even lower on the feeder advantage traits, and total advantage is quite low. And she's also the bottom 25% genetic merit for marbling. So equally as important as which ones we select, finding the troublemakers. We here would call them the cheaters, the ones that are very expensive to keep around and that cause us to incur costs, but that may not necessarily pay for themselves in the form of weaned calf weight on a regular and long-lived basis, or in the case of efficient CAB carcass production. So we think that the tool is equally as valuable at finding the troublemakers so that those can be sold and the revenue realized immediately, and so that we can then do a smarter job of picking those that might represent longer-term profitability. We've really enjoyed introducing this product. We do a lot of one-on-one breeder seminars where we color-code the results. We walk them through the trade-offs on the paperwork, and then they help us understand maybe visual differences among the animals to arrive at the keep colds. And then it goes without saying, if we can assign the sire, we can also then help them avoid inbreeding and avoid all the costs associated with the impact that might have on fertility, survival, and some of the fitness traits. I'd like to conclude with just one slide here quick. What has driven the GENEMAX Advantage product development and the downstream integration has been the adoption of high-density 50K testing among the Angus seed stock producers. In 2014, we tested just over 50,000 animals. To benchmark that, the American Angus Association registers approximately 300,000 animals per year. We're currently on pace in 2015 to test probably 70 to 75,000 animals if the first half of the year is any indication. So as we think through building applications such as this in other populations and in other countries such as New Zealand, breeder adoption of the technology at the seed stock level sets the stage. And obviously, when we have really clear-cut end product targets such as Angus Pure, it gives us a really definitive endpoint to which to select animals. Beyond that, once we have the critical mass and good coverage of the New Zealand pedigree represented in those that have been tested, as long as we have genomic predictions for the important critical economic traits and are able then to customize the economic indexes for your costs and your values of production, we can build these tools pretty readily. There is some infrastructure that needs to be developed in the way of ordering and delivering results, and as well making the results come to life to really inform the decision of keeping and culling and mating, and then long term, having the technology update itself to always be most informative. With that, it's sure been a privilege, and I'm happy to answer any questions.
That's great, Kent. Thank you very much. I think we've got time for one question. We do have a full timetable, so is there one question for Kent? Joe Fui has got a question down there, and I think we're going to get the microphone down to you, Joe, so Kent can hear it pretty clearly.
Yeah, you've obviously tested a lot of animals in America, and you've got a training population of 15,000. Obviously, in New Zealand, we haven't got that number of animals under a training population, and we can't use the training population that is in America, I gather, because the genomic background of our cattle are slightly different. How many cattle do we need for a base training population to get accurate data?
Joe, that's a great question. I'll answer that a couple of different ways. On the really fortunate front, the Angus population in New Zealand is not as large as that here in the U.S. and North America. So as long as we have a similar proportion of animals and pedigree represented within the New Zealand population, we could build tools and products such as this. So, just to use the 50,000 head benchmark that we used, that we tested in 20 last year in American Angus. So then,
Kent, I don't know.
Make sure that we have the fairly complete pedigree structure represented. Yes, Charles.
Oh, sorry, Ken. Some of the audio dropped out there. Joe, does that answer your question? It's relative, I think, is what he's saying. I think what he's saying is it's relative. And I think, we do use genetics from America and Australia, and we are represented in the resource in the States. But I think what Kent's saying is it's relative. I think we do need more animals in the resource from New Zealand. That would be very helpful. Yeah, I think that's where we're going. And we don't need 15,000. I think that's the point. Yeah. Yeah. Okay, Kent. We are going to move on, Kent. So I'd like if everyone can please give Kent a warm clap of the hands. And we'll let you go, Kent. Thank you very much.
Thank you. Thanks, everyone. Have a great day.